Hi everyone, myself Navyatha Ravi, working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. So in today's session, let us discuss the operations on relational algebra, relational calculus and types of relational calculus. So these operations includes intersection, set difference and Cartesian product. Next, intersection operator. This is nothing but the derived operations. These are nothing but the derived operations. So here we have basic operations. As I said, we have 6 basic operations like select operator, project, union, set difference, rename and Cartesian product. The derived operations, we have intersection. And next, some join operations, left outer join, right outer join, division operator. So this is nothing but what? Division operator, left outer join, right outer join. These are nothing but the derived operations. These comes under. Intersection is also comes under derived operations. That will be discussed. The joins concept will be discussed very briefly in the next coming up sessions, right? So what is here? Intersection operator is denoted by inverted U symbol. So, and it is used to select common rows from the two tables. What are the common rows are there? Those rows will be selected, right? That is what the purpose of intersection operator. So, the syntax will be table name 1 intersection and table name 2. So, here we used to represent two tables, course table and student table. So, let us discuss this one with the example. So, what is the example here? Here I used to retrieve the columns. Why I have represented project operator, that is nothing but pi, to retrieve the columns, right? So, pi, student name. What is the column that I am going to retrieve? Student name. So, here also student name. From which tables? Course table and student name. So, here I used to retrieve the student name column. That too I am using which operator? Intersection operator. That means the common names will be retrieved from both the tables. So, what are the common names here? In this, Aditya, Steve, Paul, Lucy. In this table, Aditya, Steve, Paul, Lucy. Only these 4 names. So, these 4 names will be printed. Aditya, Steve, Paul, Lucy. Only these names will be printed. Right. So, intersection is nothing but a derived operator in relational algebra. And along with this derived operator, we have some more derived operators, that is nothing but division operator and next joins. So, these concepts will be discussed later. Next, the next operator is nothing but set difference operator. So, set difference operator, let us discuss. A is nothing but one table and B is nothing but another table. So, here minus is nothing but set difference. That means I am eliminating B from A. I am eliminating the content of B from A. That is what set difference is meant for. So, it is represented by minus symbol. And let us deal this one with the same examples, course table and student table. So, what is here? The query representation, pi student name, student minus pi student name course. That means here I am eliminating the student names which are from the student table, right? So, here what is the query here? Student from the student table. Here I am going to consider student name, right? Minus. Here I have considered the same column student name from course table, right? So, these are the two tables. Here this is student table. And let's see the student course table. Let us consider the student table here, and I am considering only the student name, only this column, right? So, let us consider this Aditya, Steve, Paul, Lucy, Carl, Rick. Aditya, Steve, Paul, Lucy, Carl, Rick. This is my student table. This is my course table. Right. Here I am going to remove For example, I am going to remove student minus course. That means I am going to remove these names from this one, right? So, what is here? The student table contains these names. I am going to remove course names. What are the course names here? Aditya, Steve, Paul, Lucy. Aditya I am going to remove, Steve I am going to remove, Paul I am going to remove, Lucy I am going to remove. That means the student names from this course I am going to remove from the student names from the student table, right? So, what is the output here? Call and Rick. That will be displayed as an output. See here, the call and Rick. This will be your output. Clear? Next, what is the Cartesian product? So, here Cartesian product is nothing but which is represented by the symbol cross or else multiplication symbol, cross symbol. So, here in the Cartesian product exclusively in DBMS is nothing but here we used to join one row in one table with all the rows in another table. For example, let us deal with A, B. These are the two different tables. A contains 1x, 2y, 3z. A contains two columns. B contains two columns. That is nothing but 4p, 5q, 6r. These are the two different tables. Now, I am going to represent the Cartesian product between these two tables. That means, one row of one table will be joined with every row of another table. That means, every row. This will be joined with this one, this will be joined with this row and this will be joined with this row. The output of this one will be represented as, see here the output A cross B. Output is nothing but what? A cross B. Cartesian product is represented by cross. So, the output will be represented as 1x. The first row will be mapped with all the three rows in the other table. That is 4p. And this 1x will be mapped with 5q. And this 1x will be mapped with 6r. See, the first row will be mapped with all the three rows in the another table. And in the same manner, the second row will be mapped with all the three rows. All the three rows. That means here 2y, 4p, 2y, 5q and 2y, 6r. Right. And the third row, in the same manner, third row will be mapped with all the three rows. All the three rows. This is nothing but the Cartesian product. Have to represent. Let us deal this one with an example. Simple example. Here I have already plotted. So, what is here? The table name R, right? So, R contains two columns. These are the two columns. Next, let us consider S table, which contains two columns. Now, to represent R cross S. So, what is the output here? R contains two columns, column A, column B, AA, BB, CC. So, this is R table, two columns, column A and column B. So, what are AA, BB and CC? For example, 100, 200, 300. This is R, this is S. So, we used to represent R cross S. That means the first row will be mapped with or multiplied with all the three rows. So, R cross S will be, what is the table here? AA 100. The first row of this one will be mapped with all the three rows of the second table. Yes, that is nothing but XS 99. And the same manner, the first row AA 100 will be mapped with the second row YY 11. AA 100 will be mapped with the third ZZ 101. In the same manner, the second row will be mapped with all the three rows. That is nothing but BB. BB 200 and it is mapped with XX 99. The second row will be mapped with BB 200 YY 11. In the same manner, we used to get the output. So, the first row will be mapped with all the three rows of the second table. The second row of first table will be mapped with all the three rows of the second table, S table. And the third row will be mapped with all the three rows of the second table, right? So, here in this way, we used to represent the Cartesian product. Next, the rename operator. The name itself represents, we used to rename a table name or we used to rename a column name here. So, rename operation which is represented by row symbol, As we are dealing with relational algebra and calculus, the mathematical representations we used to represent here. So, rename operation is used to rename a relation or an attribute of a relation. Attribute is nothing but a column or else a field or else a domain, right? So, here the syntax will be row, new relation name, comma, old relation name. So, row of new relation name. That means that whatever the relation or else the name that you are going to update, the new name you have to represent here. The new name you have to represent here, and for what column that you are going to represent the new name, that column name has been represented here. That is what the syntax. So, let us deal this one with an example. Let us consider the customer table which consists of 3 columns, customer ID, name and city. And here I used to modify or rename this customer name as cust names. This is my old name, this is my new name, right? So, how I could represent? So, row means what? Here I used to rename. This is what? The new name that I am going to update, right? Cust names. What is that name? That is the new name, and that is a column name. That's why here I have represented pi symbol here. Pi represents what? The project operator which is used to represent the column names, right? So, this is the old column name, pi customer name. This is the old name which I am going to rename it as cust names. For which table? For customer table. The table name must be represented here. So, that is what the representation. So, now the output will be displayed as, instead of customer name, here I used to represent the column names as cust names. That is what the rename operator is meant for. So, next let us deal with relation. Till now we used to discuss about relational algebra and the operations on relational algebra. Now, let us deal with relational calculus. So, what is relational calculus? So, here relational calculus is nothing but non-procedural query language. Non-procedural query language means here I used to concern only on the desired output, but not how, right? So, here in the non-procedural query language, the user is concerned with the details how to obtain the end results. Only he is concerned about the end results, how to obtain the end results, but not the procedure. See, the relational calculus tells what to do, but never explains how to do. Doesn't bother. So, relational calculus is mainly of 2 types. Tuple relational calculus, shortly TRC. Domain relational calculus, shortly DRC. DRC. So, as we all know, tuple is for rows, right? Domain, which is exclusively for representing columns or fields, right? So, let us discuss tuple relational calculus with an example. So, here the notation will be P of t. Here P of t is nothing but the condition. Here T is nothing but the variable or the whatever the tuples that we used to retrieve, right? So, let us discuss this one with an simple example. This is what the condition P of t, where T represents the tuples that we are going to retrieve under which condition? Based upon the condition. Here P of t represents what? The condition. So, here what is the query? To display the last name of those students where age is greater than 30. Last name of those students where age is greater than 30. So, age is greater than 30. So, here only this row, right? Age is greater than 30. And what I am going to display here, the last name. What is the last name here? Singh. So, this output will be displayed. See, T dot last name. What have to represent this one? By using TRC. TRC means T, P of T. So, here T is nothing but whatever the rows that we are going to retrieve based upon which condition. So, here what are the rows that I am going to retrieve? The last name. Why? Because the query is to display the last name of those students where age is greater than 30. This is what nothing but the condition. So, here I am going to retrieve the last name of the student table. Here the table name that I am going to represent student table, and based upon which condition, whose age greater than 30. So here this is the variable that I am going to represent, t dot last name for student t. Here t is nothing but the variable which I have represented to retrieve a data very easy in an easy and efficient manner, right. So here for this student table, I am going to represent t as a variable. So by using this t only, I can easily able to retrieve the data from that table. So where t dot age greater than 30. So here what is the last name will be printed? Singh. Next, let us discuss with some more examples. So to display all the details of the students where last name is Singh, I want to display all the student details whose last name is Singh. So here all the names means what here? Here I didn't represent any particular column name. That's why I have represented only the variable t of which table? Student table. And what is the condition here? Whose last name is Singh. So here last name, t dot last name is Singh. Only these rows will be printed. Only these rows. Whole information will be printed. So if at all I used to represent only the column name, only one particular column, then I have to represent here t dot last name, like that, right. So next let us discuss with DRC, domain relational calculus. So the second form of relation is known as domain relational calculus. In this domain relational calculus, filtering variable is used to domain of attributes, just like which I have represented t as in tuple relation calculus. Here also we use that variable. So in domain relation calculus, we use some operators, some logical operators or connectives. So logical and, or, and, not, right. We use some of the operators, right. So it uses existential and universal quantifiers. So existential quantifier, these are some quantifier variables to represent some group of elements or some group of people. We use quantifier variables. So here we have two types of quantifier variables, existential quantifier and universal quantifier. Existential quantifier basically represents only some set. For example, some, for some, like that. So here a universal quantifier which is used to represent all. For example, for all, for every, for each. So to represent each and every person, for all persons, that universal quantifier will be represented. So to represent only some of the people, right, existential quantifier will be represented. So in DRC, we use quantifiers. Along with the quantifiers, we use some logical operators, logical and, or, and, not, along with the variable. Let us discuss with an example and what is the notation that we use to represent the DRC. So here the notation A1, A2, these are nothing but the domain names, that is nothing but the fields or else the columns that we use to represent based upon the condition, So here where A1, A2 are the attributes, P stands for the formula built by inner attributes. That is, let us discuss this one with a simple example. Let us consider one student table which consists of the three columns, first name, last name and age. Right. So what is the query here? To find the first name and age. Here what are the columns that I have to retrieve? First name and age. These are the two columns that I have to retrieve of the student table. Where the condition, what is the condition here? Student age is greater than 27. So what are the columns that I am going to retrieve here? First name and age. From which table? From student table. What is the condition here? The condition is nothing but greater than 7. That will be represented here like this. See here, the first name and age. These are the two columns that I am going to retrieve. Right. And the condition, what is the condition here? Belongs to students. Belongs to what? Student table. Belongs to student, from the student table. So these two columns belongs to student table. And what is the condition here? See here we have used logical AND operator. But in TRC we use only AND, A and D AND. But here we use, instead of representing that A and D AND word representation, here we use the mathematical representations, right? So here what is the condition? Age greater than 27. So what will be the output here? So age greater than 27, 30, 31 and 28, right? So these rows will be printed. These rows will be printed. right? So this is what about, till now we have discussed about relational calculus. In that relational calculus we have two types. So what is that one? TRC and DRC. Tuple relational calculus and domain relational calculus, right? So this relational calculus is nothing but what? Non-procedural query language. Thank you.